So recently I was searching the internet and I find very interesting trending subject. So as you see here, we have a trending subject called Vatican News reached to 100, which means a very high interest or a very high search. Also Vatican power outage, and also blackout Vatican, and also the claimed news on the Catholic News Agency about Vatican blackout and Pope Francis being arrested and some alleged rumors. So I thought that this video would be helpful for anyone who would like to understand what is the meaning of blackout. So we have to understand that all of the previous topics, or the Vatican blackout, outage, power outage in Vatican, all of this are rumors, and Pope Francis wasn't arrested or anything like this. This is all rumors and nothing is true at all. But I would like to take this opportunity to give you the meaning of blackout or the power outage for us as engineers. So in this lesson, we will discuss what is the meaning of blackout or power outage at first. So if you are new to our channel, don't forget to subscribe to our channel, hit the notification bell and subscribe in order to reach all of our last videos in electrical engineering, solar energy and more. So at first, let's see a simple electrical power system. As you see here, our electrical power system is consisting from 4 main parts, okay, or 4 main procedures. Number 1 is the generation of electricity in power station. So we start generating electrical power or generation of electricity for consumption. Then we have a power transformer, which is used to step up the voltage. So as an example, if we are generating a voltage of 10 kilovolt, we will step up to more than 100 kilovolt. Why do we do this? In order to reduce the losses in transmission lines. Then after this, we will have, after transmitting electrical power for a long distance, we have a transmission substation. What does this do? This starts to step down the voltage or reduce the voltage from, for example, more than 100 kilovolt to 66 kilovolt or 33 kilovolt and so on. Then we transmit the electrical power in lower voltage. Then we will have another distribution substation which is used to reduce the voltage again until we reach our final procedure, which is the consumption or utilization of electrical energy. So we have generation, transmission of electrical power, then distribution of electrical power. So what does power outage mean? Okay, so we have electricity, then suddenly the power outage or zero power or zero electrical power occur. So power outage, sometimes it's called the power cut, power out, power blackout, power failure, power losses, blackout. All of this could mean the same meaning, but they are not, and we will understand why. So in general, it means that the loss of electrical power network supply to an end user. So in the end, the user itself does not have any electrical power. So what are the causes of power outage? So there are many causes for power failures in an electricity network or an electrical grid. So the first one can be faults at power stations. The power stations, as an example, substations, the generation power station itself, and so on. So this can lead to failure in electrical power or power outage. Also, there can be damage to electrical transmission lines, which are used to transmit the electrical power from one location to another, as we have seen in electrical system. Also substations, distribution substations, the transmission substations, any type of substations may have fault, and also any part of the distribution system. And also it can happen due to a short circuit. And what I mean by a short circuit, it means that, as an example, we have in our electrical system 3 phase. So the short circuit can occur between A and B, 2 phases with each other, 2 phases connected to the ground, 3 phases together, 3 phases connected to a ground, or 1 phase with the ground. All of these are considered as different types of short circuit. We can discuss them in other videos. Also, it can happen due to fuse or a circuit breaker operation, which is used to protect our equipment. Okay, it can be used to protect lines, electrical lines, cables, equipment such as induction motors, induction machines, and so on. So this is an example of a damage to transmission line due to storm which happened and causes the transmission line to be damaged. So this can cause power outage. Also here we have a damage on our electrical transmission system. This can happen due to insulation failure or breakdown, which can happen due, of course, over voltage, for example. Also a lighting surge, which can hit the transmission line and lead to fault on transmission lines. Also an unbalance in current or voltage drop on the transmission lines. Also mechanical faults in transmission lines. Over voltage, the increase of voltage can lead, of course, to the over voltage phenomena and lead to insulation failure and other damaging effects. Also, we can have under frequencies. The frequency decreases below a certain limit, and the reversal of powers, instead of getting the electrical power from electrical power station to motors, for example, the motors will become a generator due to the presence of faults. Also due to the temperature rise. So what happens in critical sites, as an example in hospitals or mines? Okay, so we have in hospitals, we have patients. We should have power or electrical power all the time. Okay, so we have here a utility power. This is the main electrical source of power, which is providing power to critical places or locations such as hospitals and mines. Okay, so in order to keep the electrical power in these locations, we should have a backup power sources such as a generator. So what happens here is that we have now two sources of power. We have the utility power and we have the generator power. This is a backup generator or a standby generator. So we have here something which is called a transfer switch, sometimes called the ATS or automatic transfer switch or manual transfer switch. So what does this do? So during the normal conditions, we have a distribution panel here. This one provides power to our site, as an example, hospital. Okay, so this distribution power takes electrical power from the transfer switch. So at the beginning, in normal operation, the utility power provides power to the distribution panel by using this switch. This switch is taking the electrical power from utility power to this distribution power panel, which provides power to the hospital, for example. Now, in case of having a fault on utility power, this automatic transfer switch, what does it do? It transfers the power from the utility power grid to a portable generator. So we take electrical power from the generator to the distribution panel. So that is the benefit of something which is called the ATS or automatic transfer switches, which is usually automatic, and sometimes it can be manual switch. Now, what are the different types of power outage? There are three main power outage. Number one, a transient fault. Number two, a brownout. And finally, the blackout, which is the one we want to understand in this video. So first, the transient fault. The transient fault is a loss of electrical power which is typically caused by a fault on power line, such as the faults which we discussed before. So as you see here, this is the voltage. The voltage is normally normal condition. Then suddenly a fault occurred, so the power drops or the voltage drops to 0. Then after a certain time, or if it is automatically restored, if this was a temporary fault, not a permanent fault, then after a very small time, in milliseconds, the power will return back. So the voltage will start to increase again to the normal value. So this is called a transient, and sometimes it can be a temporary fault, not a permanent fault, okay, which can be restored automatically using circuit breakers. The second type, which is the brownout. What does a brownout mean? It means that there is a drop in voltage in an electrical power supply, or the voltage not at the constant value, for example at 220 volt, but it is lower than this value, as an example 210 or lower. So this is a phenomena which happen in electrical power system when the demand for electricity is very high. So when the demand of electricity very high, the voltage will start to decrease. Why? Because the electrical current is very high. So when the electrical current increases, the losses in transmission line and the voltage drop on transmission line increases, which will lead to a final small voltage at the end user. So the term brownout comes from the dimming experienced by lighting when the voltage sags. So when the voltage starts to decrease, what will happen? As you see here, it causes poor performance of equipment such as induction motors or even incorrect operation. So as an example of a brownout phenomena, so this is an example of a 220 volt. And as the voltage decreases, you will see this is the dimming action, or the dimming phenomena. This happens when the voltage starts to decrease due to the brownout phenomena, or when the demand of electricity becomes very high. So here is another example, which is the torque inside a motor. So the torque inside, or the maximum torque inside an induction motor, you will see that it is dependent on the voltage square. So when the voltage decreases, the maximum torque will start to decrease, which means our induction motor will produce lower torque. Okay, this happens in the brownout phenomena, and of course it can lead to if the voltage decreases below a certain limit, it can cause under voltage, which will lead to shutdown of electrical machines. Now the last one is the blackout. So what does a blackout mean? It means that the total loss of power to an area. So when I say total loss of power, it means a large area, a loss of electricity in a very large area. And this is the worst or the severe form of power outage that can occur in an electrical power system. So it is not a transient fault, which can just happen for a small time, or a brownout, which means just a decrease in voltage due to the presence of high demand, but this is a blackout. It means that there are lots of electrical power stations which are out of service. So blackout can result in electrical power stations tripping. Okay, so the tripping means that an electrical power station goes out of the grid, and this can cause another power station to go out from the grid, and another one go out from the grid, and so on. So many electrical power stations will go out from the grid, and this is really hard to recover from quickly. It needs a certain type of operation in order to start putting this power station to the grid and synchronizing them together. So outages, this can last from a few minutes, depends on the blackout severe condition. It can last from a few minutes to even a few weeks. depending on the nature of the blackout and the configuration of the electrical network. So here is a small example of the difference between brownout, power interruption, or a small interruption of electrical power, or a transient fault, or the blackout. So as you see, the blackout can cause the brownout or the dimming of the electrical bulbs, or this is caused of course by high demand in electricity, which will lead to reduced voltages. The power interruption, loss of an electrical power in a small area. Okay, so but however, the blackout for a large area, total or partial system collapse, which can lead to loss of electrical power. And as you can see, the blackout is the worst type of power outage. So I hope this video gave you a clear idea about the power outage, the blackout, brownout, and the transient fault. So in the end, if you haven't subscribed to our channel, don't forget to subscribe and hit the like button and the notification bell to get all of our last videos. Thank you and see you in another lesson.